Hi folks, this is number 10 from the Unit 3 assignment. So they give us this function that has two unknowns, and they give us that there's a horizontal tangent at 2, -1. They want us to determine A and B and sketch the function that results afterwards. Okay, so again, we've got two unknowns here, so we're going to need two pieces of information, and in fact we do, because the fact that there's a tangent at 2, -1 tells us that 2, -1 is on the curve. And if there is a horizontal tangent there, it means the derivative is 0 at 2. So there's our two pieces of information. Okay, so let's set up a system of equations, hopefully. So often I start with the derivative, because if I'm working with a polynomial function, the derivative will actually be simpler. Here, that's not necessarily going to be the case. So I'm going to start with the point 2, -1. So when y is equal to -1, x is equal to 2. So here we have 2a plus b, and here we have 2 minus 1 is 1, and 2 minus 4 is -2. Okay, so rearranging here, I'm left with 2a plus b equals, multiply that -2 there, so +2. So there's my first equation. Okay, so now hopefully come up with a second equation for us to solve the system. So here now we have to work with the derivative, and we know that at 2 the derivative should be 0. So start by determining the derivative. So numerator is a, and then I don't want to work with the factored form, especially when I find the derivative of the denominator. So let me multiply this out. So that gives us x squared minus 5x plus 4. Okay, so then minus ax plus b times the derivative of the denominator, which now would just be 2x minus 5, all over x squared minus 5x plus 4 squared. Okay, so as we said, the derivative is going to be 0 when x is equal to 2. So here we have a times, so when x is 2, we've got 4 minus 10 is -6 plus 4 is -2. Okay. And then here we have minus, again, x is 2, so 2x plus b. And here, 2 times 2, 4 minus 5 is -1. And the denominator, well, we already calculated that, that's -2 squared. Okay, so let's simplify here. So we have -2a. Here we're subtracting a negative number, so it'll just become an addition. So we're just left with... sorry, I just noticed here a little error. This should be 2a plus b, because it's x we're replacing by 2. Okay, so just be careful there. 2a plus b. So this is going to be plus 2a plus b over 4. And in fact, here this works out pretty nicely because the a terms cancel out. So I'm just left with b is equal to 0. So it turns out the derivative still ended up being the easier one. Okay, so now I can go find a. So 2a plus 0 is equal to 2. So a is equal to 1. Okay, so in the end, our function ended up being just a equals 1, b equals 0. So x over x minus 1, x minus 4. Okay, so this is what we now have to graph. Okay, so we'll go through our process, which is to, start by first determining what we can get from the function itself. Okay, so the domain of the function is just all real numbers except 1 and 4. Okay, since that makes the denominator 0. Our x-intercept, well, the only thing that'll make this equal to 0 is when x is 0. And our y-intercept, well, when x is equal to 0, as we already saw, y is equal to 0. So x and y intercepts are both 0. Okay, we have our vertical asymptotes here. That's when the denominators are 0. So x equals 1 and x equals 4 are two vertical asymptotes. Our end behavior, well, here, since the numerator has degree 1 and the denominator has degree 2, we know that this has to approach 0. So the limit as x approaches positive or negative infinity is going to be equal to 0. So there's our horizontal asymptote. And I suppose the last thing we can figure out here is what is the sign of the function. So here, function can change sign at its x-intercept or at its vertical asymptotes. Okay, so if we put in -1, we've got negative, and these are both negative, so negative over positive. Function's got to be negative there. We put in 0.5, so we have numerators positive and denominator, well, they're both negative, so negative times negative is positive, so the result is positive. Let's pick x equals 2, so numerator's positive, and here we have this one's positive, that one's going to be negative. Okay, so end result is negative, and let's put x equals 5, numerator positive, and everything in the denominator is positive, so there we go. Okay, so that's all the information we can get from the original function. So let's now do step 2, which is using the derivative. Okay, so here I guess we can go back and make use of the fact that we already sort of found the derivative here. I don't think that really helps us that much. So let's just kind of redo it from scratch. So here, what do we have? We have derivative of the numerator is 1, okay, times the denominator, which is x squared minus 5x plus 4, okay, minus numerator function, which is x, times the derivative denominator, which is 2x minus 5, all over x squared minus 5x plus 4 squared. Okay, so let's clean this up. We have x squared minus 2x squared, so negative x squared. Okay, we have negative 5x plus 5x, so that disappears, and then we're just left with plus 4. Okay. Okay, and so here we're looking for the derivative to be equal to 0, and so we've got factor this out. So if we factor out a -1, we're left with x squared minus 4, which of course factors to x plus 2, x minus 2. Okay. Okay, and so now we have our critical points, which are plus and minus 2. Okay, so let's now determine the signs of the first derivative, so the increasing and decreasing behavior, and help us determine what's happening at the critical points. So here we're going to look at -2, and where the denominator is equal to 0, so we're still looking at 1 and 4. Okay, we also need 2, which is another critical point, and 4. Okay, so here I notice that the, let's work with this one here. Denominator is always positive, so I don't have to worry about the denominator. So if we put -3 squared, that's 9. -9 plus 4 is negative, so negative here. Okay, then between -2 and 1, let's put x equals 0, so -0, 0 plus 4, okay, positive. Okay, so here we see that we've got a min at -2. Okay, so between 1 and 2, let's put in 1.5. So 1.5 squared, well, is less than 4. So you have some negative something less than 4 plus 4. That is going to be positive. Okay. And then between 2 and 4, let's put 3, so -9 plus 4, this here is negative. Okay, and then here we've got when x is greater than 4, so again -25 plus 4, that's going to be negative. Okay, so that means here positive to negative around 2, that means we have a max at x equals 2. So here when x is equal to -2, let's stick this into the original equation. So we've got -2 over, right, let's just actually calculate it here instead of doing everything in our head. So when x is -2, so I have -2, -2 divided by, so -2 minus 1 is -3 times -2 minus 4 is -6. Okay, so -0.11. Okay, notice I don't put it in fraction form since I need to graph it. I need to know what this is as a decimal. Okay, and so here we have a max at positive 2, so 2, and let's put in positive 2 here. So what do we have? We have 2 divided by 2 minus 1 is 1 times 2 minus 4 is negative 2. Okay, that was actually pretty easy. Okay, and so here we just have negative 1. Okay, so 2 negative 1 is going to be our max. Okay, now the last thing, and this is going to be the tough one. Now on a test, if I was asking you to graph something like this, as I said, I'd likely provide for you the first and second derivatives so that you don't have to go through all this, especially here. Taking the derivative of the first derivative is going to be kind of a tough proposition. Okay, well, let's go ahead and do that. Okay, but like I said, on the assignment or on the test, so on the assignment, I'd expect you to have done this using a derivative calculator, but let me give myself a challenge here. Okay, so derivative of the numerator is negative 2x times the denominator function, which is x squared minus 5x plus 4 squared, minus, so the numerator is negative x squared plus 4 times the derivative of the denominator. So I might run out of room here. So it's 2 times x squared minus 5x plus 4. Okay, and now I have to take the derivative of x squared minus 5x plus 4, which is 2x minus 5. Sorry for the mess there. And all over x squared minus 5x plus 4 to the power 4. Okay. Now again, in order to make this doable here, is I'm going to use the fact that both these terms in the numerator have a common factor of x squared minus 5x plus 4. Okay, so I'm going to factor out one of these, so it's going to go from there, that factor is going to go from there, and it'll cancel out with one of my factors in the denominator. Okay, so I'm not going to write all that out, but essentially I'm just taking the factor of x squared minus 5x plus 4 from each term, and then reducing it with one of those factors in the denominator. So what we're left with now is negative 2x times this expression here. So that gives me negative 2x cubed plus 10x minus, 10x squared and minus 8x. Okay. And now I've got the minus 2. Okay, and I have to now multiply these two binomials. So negative x squared times 2x, negative 2x cubed. So negative x squared times, where is this? Negative x squared times negative 5. So that's plus 5x squared. Okay, and so now we've got 4 times 2x, so plus 8x. And 4 times negative 5 minus 20, all over this thing cubed. Okay, and now let's simplify. So we have negative 2x cubed plus 4x cubed, so negative 2 plus 4, so that's 2x cubed. We have 10x squared minus 10x squared, so that's good, that disappears. Here we've got negative 8x minus 16x, so that's minus 24x, and then here we have negative 2 times negative 20 is plus 40. Okay, over this whole thing cubed, and here we can factor out a 2, so x cubed minus 12x plus 20. Okay. And I believe this thing in the numerator doesn't factor nicely. So even if you try to use the factor theorem, it doesn't work. So in this case here, you've got a couple of options, okay, at least for your assignment. You can either graph this function and determine, because remember, we're looking for where this is equal to 0, okay, or you can look up an equation solver online and just stick it in there. So that's what I'll do if you just give me a second. Fortunately, I can't show you that here, so I'm going to put in, let me just a second, x cubed minus 12x plus 20 equals 0. Okay, and press go. And it looks like there's only one solution, negative 4.1. Okay, so here x equals negative 4.1 gives you the, I'm back here. Okay, so negative 4.1 is the only solution that gives you 0 there. Okay, so now what we have to do, of course, is now test the second derivative here. So again, we have negative 4.1. Make sure we actually have a point of inflection, and then of course there's 1 and 4. Okay, and really just to save time, because this video is getting very long, I'm just going to check to see if this is a point of inflection. Okay, so if I put in negative 5 into here, so let's check the numerator. Okay, so, we got negative 5 cubed. Okay, minus 12 times negative 5 plus 20. Okay, so we have negative over, and now let's put it into this denominator here. So negative 5 squared is 25 minus 5 times negative 5 plus 4. Okay, which is a positive, and when I cube a positive, still get a positive. Okay, so it's negative to the left, and let's stick in, I guess we can stick in 0 here to make life easier. So 0 minus 12 is negative 12. 0 minus 0 plus 20 is, so we got 20 we got positive in the numerator, and in the denominator, let's stick in x equals 0, and we'll end up with 4 cubed, so positive over positive is positive. Okay, so we're going from concave down to concave up, so we do have a point of inflection at negative 4.1. Okay, and let's figure out what the y value is. Okay, so here we've got in the numerator negative 4.1 divided by, and in the denominator we have negative 4.1 minus 1, so negative 5.1 times, and negative 4.1 minus 4 is negative 8.1. And so here we've got about negative 0.0, we've got about negative 0.1. Okay, negative 0.1. Okay, and again, to save myself some time, I didn't prepare a graph, but let's graph this here. So we have our x-intercept at 0, and if I look at my y values of all my important points, it looks like negative 1 is the smallest one, so one furthest away from 0. So I guess what I'll do here is, and this is a pretty small number, so I will go negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll call this negative 1. Excuse me. And what do we need for our x values? So we need to go from 1, 2, 3, 4 to get in our our vertical asymptotes, negative 1, 2, 3, 5. Okay, so here we have our x-intercept. Here we have one vertical asymptote. Here we have another vertical asymptote. We have our maximum at 2, negative 1. Okay, and we're going from increasing to decreasing. So this will look like this. Something like that. Sorry, I have to take a drink before I start coughing. Okay, so let's take a look at what happens greater than 4. Well, nothing interesting happening, and we know that it approaches 0. We know we have a vertical asymptote, and the function has to be positive, so it's going to look something like this. Okay. So on the other side, let's not forget we have our min at negative 2, 0.11. Okay, so here somewhere there we've got our min, and then I'm really exaggerating it here so I have a bit of room, and then we have our point of inflection as negative 4.1, negative 0.1, so just slightly above that other one. There's our point of inflection. Okay, so we know that it's approaching 0 and is going to be concave down that point, so try to make it a little concave down, and then from this whole area here it'll be concave up, so it'll go down to the minimum and then cross the x-intercept, and then the function will go positive and approach the vertical asymptote. Okay, so this video is way too long, so we're going to stop it here. Okay, so remember what I said, I would not expect you to determine these derivatives and